A radioactive substance has a half-life of 82 days. 168 grams are present when time t equals 0. Find the amount remaining after 36 days. Okay, so this is a radioactive decay problem, and I like to use an intuition for these as much as possible and kind of memorize or minimize memorizing formulas. This will be time. This will be the amount at t at any given time. This is actually supposed to intersect at 0. Maybe I can just move the whole axis over. Oh, that's terrible, but I'm going to go with it. Okay, so from here then, I'm going to write down the data we know. So at this point here, this is going to be n0, the amount we have at time t equals 0. This will be time 0. This right here, I'm going to say is when we have half the amount we started with, which would mean that this right here would be the half-life, the time that it takes for you to have half the amount. So this is an exponential decay. An exponential decay is going to have the formula or format of the amount existing at time t is going to be the amount you started with times the exponential negative lambda t, where lambda is just some sort of constant, some sort of decay constant. And so we're going to use the information we're given in the beginning to determine what this decay constant is. I'm going to say that the amount we have is going to be n naught over 2, basically half. That's supposed to be a 0, not a 6. And that's going to be equal to n naught, because that's just a constant, our initial amount, e to the negative lambda, that's unknown. And then our t here is going to be our half-life, which is going to be 82 days. Ooh, that's good contrast, good contrast. 82 days. So now we want to solve for lambda. Dividing both sides by n naught, we have n naught over 2 times, and I'm just going to write this as 1 over n naught for cleanliness sake, for clarity, e to the negative lambda and 82. I'm just going to leave off days for convenience. The n naught cancel, and so we're left with 1/2 equals e to that. So we have natural log of 1/2. That's how we get rid of the e, equals negative lambda 82. And I'm going to flip this for convenience. And so we have negative 1 over 82 times natural log of 1/2 is the value of lambda. So going to wolfram. So we do negative 1 over 82 times the natural log of 1/2. And that should give us a positive number. Yep, because natural log of 1/2 will give us negative. The negative is also negative, double negative, positive. So 8.45 times 10 to the negative third. So we have equals 8.45 times 10 to the negative third. So now that we have our lambda, we can go back to our original equation and then find out the amount remaining at our mystery time, i.e. 36 days. So the amount at any given time, n of t, is our initial amount, 168, multiplied by e to the negative, and I'm going to write this as 8.45 times 10 to the negative third, and there's that negative still in there, times t. Now this is, the units for this is actually going to be per days, 1 over days. And so I'm going to write that over here, per days real quick. And we're going to multiply that by the time, which is 36 days. And so we're raising the e to a dimensionless value here, because the days cancel and we're left with just those two numbers multiplied together. Equals, I'm going to go to wolfram for this. Yep, okay. Whoop, whoop. So this is our value of lambda, our constant. We're going to multiply that by 36. Put in another parentheses just for good measure. Multiply by negative 1. Raise e to that power. Put another parentheses because it's hard to have too many parentheses in life. When you're uncertain in life, just add in another parenthesis. Okay, so now, we have 168 e to the that kind of mess. And the result is 124, 123.9. I'm going to round that to 124. So for here, going back to this, we have 124 grams. Now, I know there are formulas which you can use Halflife to convert to a decay constant. Not worth it, unless you're just doing this and have to do it as quickly and efficiently as possible. I think you're often much better off trying to reason your way through it and going through this whole process and using that to determine the amount that's decayed and the amount that's left. Memorizing, I have the memory of a goldfish, so the fewer formulas I memorize, the better. Hope that helped. See you next time.